Hello. So as you are watching this video, please make sure that you are pausing and taking good notes. Make sure that you write all these examples down. If you have questions, make sure that you circle any problems that you don't know how to do. Feel free to email me. I do have limited availability when I'm in Central Missouri, so I'll get back to you just as soon as I can. Work on the homework during class so that you don't have homework over break. Get as much done as you can. Okay, so remember how I've been saying all along that exponents and logarithms are very closely related. They are. Just like we have exponent rules, we also have rules for logarithms. The exponent rules and logarithm rules are very closely related. A couple of days ago, we were talking about the exponent rules, and we're going to tie those into the logarithm rules. The other day, we talked about when you're multiplying and the bases are the same, you can add the exponents. So if you have a to the power of m times a to the power of n, you add those exponents together, so that's a to the power of m plus n. If you're dividing and the exponents are the same, you subtract the exponents. And if it's power to a power, you multiply the exponents. So it's a to the power of mn. We can use those rules for logarithms as well. So if it's a log of, let's say we have base a of mn, so the argument has a product in it. What you do is you can split that up using addition, just like we did with the exponents. So it's log base a of m plus log base a of n, just like that. And then if the argument, has a quotient, we can split that up with subtraction. Log base a of m minus log base a of n. If it is a power, so if it looks like log base a of m to the power of n, what happens is that power comes floating down like a butterfly to become a multiplication problem, becomes a constant in front of the logarithm, like that. So what that allows us to do is a process called expand and simplify. And this is going to primarily be no calculator. If you look at example 1 here, the base is 10. So we're going to take this argument of 200 and we're going to break this up in such a way that we can simplify it without a calculator. So 200, so think about this, if the base is 10, is there, let's see, so 10 to what power? Okay, so if you take 10 to the power of 1, that's 10. 10 to the power of 2, that's 100. 10 to the power of 3, that's 1,000. Does one of those numbers go into 200? Yeah, 100 goes into 200. So we could split this into log of 100 times 2. That's the same thing. Oh, now it's multiplication. So we've got an argument that's being multiplied, so we can write that as log 100 plus log 2. Okay, now log 100, base is 10, so log 100, 10 to what power is 100? Okay, well that's 2 plus log 2. Now that's simplified. Okay, now let's look at number 2. Log base 4 of 20. So think of a power of 4 that we can put into 20. Okay, well 4 times 5 is 20. So we could write that as log of base 4 of 4 times 5. Okay, well now we can split that up. Log base 4 of 4 plus log base 4 of 5. Okay, well, log base 4 of 4, that's 1, plus log base 4 of 5. Oh, well, okay, that's done then. Okay, so pause and see if you can do number 3. So hopefully you knew that it's division, so you write it as a subtraction. Log base 3 of 27, that's 3, minus log base 3 of 5, and then you're done. Okay, so let's keep going. It is really important that when you're writing these problems that the log is clearly on the side of the argument. It's not in the numerator, it's not in the denominator, it's clearly on the side, and you're not using slanted fraction bars. This one has multiple things going on. So what we need to do first is we need to take care of the division by doing a subtraction. So we're going to do log base 4 of 16x cubed minus log base 4 of 7. Now, how are you going to take care of that multiplication? So go ahead and take care of that multiplication and then come back. Now, what is log base 4 of 16? Okay, log base 4 of 16. 4 to what power is 16? Okay, well, that's 2. So 2 plus, okay, now let's take a look at this. There's a butterfly up there in that sky. This 3 is going to float down. It only floats down in front of its own log. So that becomes 3 log base 4 of x minus log base 4 of 7. And then you're done. That's your answer. This one also has multiple things going on. For anytime you have a radical, you have to remember that if you have like a square root, that's the same thing as a 1/2 power. If you have a cube root, that's the same thing as a 1/3 power. If you have a fourth root, that's the same thing as a 1/4 power, etc., etc. So the first thing I would do on this is I would change this radical to be a 1/4 power. So it's natural log of, okay, now I'm going to have to use lots of parentheses here, x cubed, x squared plus 3, all raised to the 1/4 power. Now you can go about doing this in several ways, but I think what I would do first, I would float that exponent all the way down. So it's 1/4 of the natural log of x cubed, x squared plus 3. Now we're going to have to be careful and keep that 1/4 with everything. It's going to have to stay attached to everything that we split up. So inside here, this big argument in here, there's a multiplication. So you're going to split that multiplication up. But keep that 1/4 involved. So it's natural log x cubed. I'm going to keep that involved. Keep that 1/4 every time you split it up. Okay, now pause for a moment. Look at that. You keep the 1/4 every time you split up the natural log. Okay, now look at what you got. What else can we do? This x squared plus 3. Do we have a rule for breaking up addition? We have a rule for breaking up multiplication. We have a rule for breaking up division. We have a rule for breaking up power to a power. But we don't have a rule for breaking up addition. And this x squared is part of that addition. So we can't do anything inside here. We just got to leave that alone. But this x cubed, there's another butterfly. It's going to join this butterfly. So you're going to float that down, and it becomes another multiplication. So it's 1/4 times 3 times natural log x plus 1/4 natural log x squared plus 3. Sorry, I'm doing this at the end of 8th hour. Can you tell? Okay, there goes the bell. Okay, yeah, 8th hour. Okay, so then you multiply those two fractions together, so you get 1/4 times 3, that's 3/4 natural log x, plus 1/4 natural log x squared plus 3. Okay, there's likely to be more noise going on here, so just bear with me. Now we're going to go the other way. So now we're going to condense, and the first thing that I do when I'm condensing expressions is I float the butterflies up. So this 1/2 is going to float up, this 3 is going to float up. And now you look at the fact that it's addition, and when you're adding, you multiply the arguments. So this x to the power of 1/2, that's the new argument, is going to be multiplied by the x plus 1 to the power of 3. Now x to the power of 1/2 is the same thing as the square root of x. And then this one is x plus 1 to the power of 3. So we're going to write that as log of the square root of x and x plus 1 to the power of 3, like that. So you float your butterflies up, and then you multiply the arguments. And then try do number 2 on your, or number 7 on your own. So first you float your butterfly up. It's subtraction, so you divide your arguments. Look at your answer very carefully. Notice the natural log is on the side. You don't have one in both the numerator and the denominator. It's just on the side. You can write the answer without parentheses around the argument, but you have to have the natural log on the side. It's got to be clearly on the side. It's a very good idea to put your argument completely in parentheses like that. Okay, then the last one, well, not the last one, number 8. Okay, so this is a big one. We're going to float that butterfly all the way up. Okay, now look inside here. The addition tells you to multiply your arguments. Okay, so now I've got this big argument here. And then the 1/3 is the same thing as a cube root. So it's the cube root of x plus 1. And then you're done. Okay, now JUCO likes to put a problem like number 9. And the reason they like to do this is because they like to sneak a subtraction in the middle of a problem. And so when you see a problem like this, what you need to do is you really need to be careful, and you need to rearrange this problem and rearrange it in such a way that the subtractions are all on the end. So as you're writing this problem down, go ahead and rearrange it so that all the subtraction is on the end, at the very far end, and all the addition are together. It's going to make a difference. Please trust me on that. Okay, now you're going to take care of all of your butterflies first, then take care of all of your addition, and then we're going to take care of the subtraction. So this is 5 squared, that's 25. Square root of 9, well, that's 3. Okay, now this is all multiplication. So 25 times 3 is 75, times 2 is 150. So it's log base b of 150 minus log base b of 3. Okay, so that's log base b of, we divide now, 150 over 3, which is log base b of 50. That's your answer. Okay, we're going to do one more problem. One of the things that you need to be familiar with is called the change of base formula, and this is going to come in really handy next week, well, the week after spring break, when solving exponential and logarithmic equations, and we have to do the exact answers only. The change of base formula, you're going to be asked to evaluate using the change of base formula. So write down the formula and then come back. So you would write log base 10 of 3, because that's the log of the argument, over log 7. Then you would type it into your calculator. If you don't have the updated calculator, you would use lots of parentheses and type it in as this screenshot shows you. If you have the updated calculator, just use your fraction shortcut. Make sure you put approximately, because you are rounding, and then round to 3 decimal places, and that is using the change of base formula. The assignment is on your syllabus. Please make sure that you work on that for the rest of the class period. Have a great break. See you later.